Okay, to start our lesson off today, we're going to start by you trying to find some patterns. So notice this page has already been done for you, but your job is going to be to look at the equations that are given and the tables that match them, and then the graphs that match them, and see if you can find any patterns. So what I would like for you to do now is pause the video and try to find 5 patterns if you can. There's 5 total, but you may only see a few. So pause and write down any patterns that you notice. Okay, so some of the patterns that I notice when I look at this. So first of all, equation 1 is different than all of the others because it does not have an x squared in it. If you remember from before, that's because equation 1 is an example of a linear function, which is why you're given a straight line. The table, well, all right, we'll just leave that there. Okay, equations 2, 3, 4, 5, and 6 all have x squared, and notice that the shape of those lines is all in a U. All right, so we're going to take some notes about that on the second page. Also, equation 5 should stand out to you. So if you notice here on graph number 5, it is a U shape, except this U shape is going downward. And if you look at the equation, one thing that hopefully should stand out to you is the fact that this has a negative sign in the very front. That negative sign is what causes it to open downward. All right. The last thing that there's 2 more things to notice. If we look through our tables on 2 through 6, you should notice that the tables all have patterns. So when you look here, they all kind of have a spot where they turn around. So this is like -4, -7, -8, and then it goes back to -7, back to -4, 1, and 8. That happens on all of these graphs. And then if you were to find those specific points where these like middle points, you'll notice that on the graph, those become the lowest point or the highest point. They're the turning point when you actually look at the graph itself. All right, last little thing to notice, and it has to do with the zeros. So take a second to look at the zeros in all of the tables. And this should actually just be a reminder for you all from a little while back. All of these zeros correspond with where we're hitting the y-axis. So remember, all of those zeros are the y-intercept, and that may not stand out to you, except notice, for instance, in question 4, the 0 is -7, which is this number in the end of the equation. On 5, the 0 is 1, which is the last number in the equation, that constant term. Same thing on 6, right? On number 3, because this one's a little bit different, it's because the constant term is 0 because there is no term in the equation with an x. So those are some of the patterns you should have noticed. In some way, you need to probably have those written down as a bulleted list. You do not need to copy this page itself, but you probably need to have those patterns written down in some form or fashion for your own reference. Okay, so here's where we're going to get some more specific notes. This first page is just going to be about the shape itself. We're not going to talk specifically too much about the equation. All right, so a quadratic function. So this word quadratic, we've talked about a few different types of functions. We've talked about linear, which is like y equals mx plus b. I'll write that down, mx plus b. We've talked about exponential, which has a percent rate of change, right? And that one kind of just goes up really, really steeply. And if we look at the equation, it's like y equals some number to the x power. So now we're going to talk about quadratic functions, which have a different shape in and of themselves. So for our quadratic function, x squared is what makes something quadratic. So it's important for you to know that. Anytime you see x squared in the equation, that's going to be a quadratic function. The shape of a quadratic equation is called a parabola. And a parabola is like a U-shaped graph, and it may open up or down. And what we need to note right here is a few different things about a parabola. So we talked about how in the table all the points kind of mirrored each other. So there's this special line that runs down the middle of the graph, and it would have been really nice if they would have called it the mirror line, but they don't. This line is called the axis of symmetry. And so you will notice it goes right down the middle, and it cuts the graph perfectly in half so that there are mirroring points on the left and the right at all levels. So for instance, like -1 is 2 jumps away from the axis of symmetry, and so is 3. Right? There's another mirrored point up here at -2, 5, and 4, 5. Right? Those are both 3 jumps away. One thing that is special about the axis of symmetry, and it's easy to remember, this line cuts through the x-axis, and because it's axis of symmetry, it's easy to remember that it is always going to be an x equals line. All right, the next important point about a about a parabola, all right, is this point down here. This turning point is called the vertex. So you may want to say that the vertex is the turning point. And it is always going to be on the axis of symmetry line because it's obviously doesn't have anything to mirror with because it's where the graph is going to turn around. Also, the vertex is usually it is either the highest or the lowest point on the graph in general. All right, a few other points of interest that we want to note. We already talked about this one. On the y-axis, this is my y-intercept. And our y-intercept, because it's a point on the y-axis, is always going to be written in the order 0, y. And you may want to remind yourself that that comes from that last number in the equation. All right, a few more points of interest to talk about, really just 2 more specific points, and those are these points on the x-axis. Now, it's important for you to note that these 2 points have like 3 different names, and you do have to know all 3 of them because they ask them in all these different ways throughout testing. So these points on the x-axis, they are called x-intercepts, or they are also called roots. That's a common one that we're going to use. Solutions. And then zeros. And zeros is the term that your calculator uses. So if you see any 4 of those words, they all mean the same thing, the points on the x-axis. And notice that there are 2 of them. That is because this is x squared. All right, so I put another little star in your notes right here. So just write down what I'm saying. The degree of a polynomial is the same as the number of roots. So because all quadratic equations are x squared, or x to the 2nd power, they always have 2 roots. All right, so this right here, there will always be 2 roots, and we're always going to write them x comma 0, because they're... All right, so the only other basic thing that we need to talk about is domain and range. You all know that if you look at an equation and they don't give you a domain, that for the most part our domain is always all real numbers, and that's going to hold true for now also. So our domain is going to be all real numbers, and our range is going to be just a little bit different. So range, in this specific example, think about the fact that this is range or y values, and notice that this graph is not going to cover all of my y values. So like I do have y values of 5, 4, 3, 2, 1, right? Because I can find points along that those y values. But the lowest point this ever gets to is this vertex, which is at -4. So we write the range to say that y is greater than or equal to -4. That's because -4 is the lowest that it ever goes. So that's why it has to be greater than or equal to. And then obviously y, because we're talking about the y values. All right, so these are the general notes. We're going to do one example together about how to kind of graph and get some of this information just from the equation alone. Okay, I lied. We're going to do one example first where they give us the graph and we just identify the parts. So the vertex, remember, is the turning point. So you want to find where this highest point is. So this is going to be my vertex. And when we write that out, we're just going to write it as an ordered pair. And that point is at 2, 1. Remember, axis of symmetry is the line that cuts straight down the middle. This line is cutting through the x-axis at 2, which gives us x equals 2. You may notice, and you should notice, that this x value is going to be the same as it is in the vertex, and that will always be true. All right, roots, remember that's another word for the x-intercepts. So notice it's crossing the x-axis here at 1 and 3. Those are two separate points, so we want to list that as 1, 0 and 3, 0. Make sure you list them separately. Y-intercept, we've got going on down here where it's touching the y-axis. So that's going to be at 0, -3. Remember, we're putting this in the y spot, right, because it's a y value. Domain, we just talked about, is always all real numbers. And then range, okay, that's our y value, so I know range is going to be y. Think about if our parabola, these arrows tell me that our parabola is going down forever, so my range is going to be less than or equal to. So if the parabola opens up, y is greater than or equal to. If the parabola opens down, y is less than or equal to. And then we want to find, well, what is the highest y value then? And it looks like this y value maxes out at 1. So y is less than or equal to 1. Another way to kind of cheat that is to look again at the vertex, right? The y part of the vertex helps you with the range. Okay, so you are going to have some problems where you just need to identify given the graph. All right, so this last example, they're going to give us an equation, and we're going to talk about just a few pieces of information that we can get from the equation to make the graph. We can't find everything, but we'll find what we can. All right, so the very first and easiest thing that should stand out to you, actually a few things that you should make a note of. First of all, this negative in the front tells us that my parabola is going to be opening downward. So we want to make sure that in the end our graph looks something like that. Remember that this -4 at the end is going to tell us our y-intercept. So the first piece of information I'm going to list here is my y-intercept. I'm going to label that my y-intercept is going to be at 0, -4. And then I can actually go ahead and graph that as well. All right. A part that we have not talked about how to find yet that I'm going to teach you right now is how to find the axis of symmetry. All right, there's a formula, and it's not too bad. You're going to see it later. The formula is going to be x equals -b over 2a, which seems random, but like I said, it's going to come back to us here next week. So when we use this formula, the a and the b, in any quadratic equation, they are a, b, and c. So a is the number with x squared, b is the number with x, and c is this constant that's by itself. All right, so if I do x equals -b over 2a, that means I'm going to do -8 over 2 times -2. All right, remember I'm pulling that 8 and the -2 from the equation. And then I just work that out, -8 over -4, which gives me +2. So my axis of symmetry is x equals +2. I'm going to go ahead and draw that as a dashed line. Okay, now this part is very important. Remember, there is a point that's always on the axis of symmetry, and if you look back at your notes, you should realize that that is the vertex point. So to find the vertex, we're going to plug in that x equals 2 value into the equation. So I'm going to do y equals -2 times 2 squared plus 8 times 2 minus 4. And when we work that out, we should get 4. So that's y equals 4. So when I write my vertex, remember I plugged in 2 for the x value, and I got 4 for the y value. So I'm going to plot that point, 2, 4. Now remember, this parabola, you only see 2 points right now, but it's a U shape. This point right here is the vertex, so it's going to be the highest point, and this parabola is opening down. So I'm just going to make my graph, and I'm just trying to make it mirror as best I can on both sides so it looks about equal. All right, so from this original equation, which by the way is called standard form. All right, that's what that is called. From that equation, we have found a few things. One, we found how it opens. And the second thing we found is the y-intercept, which we were able to graph. We found the axis of symmetry, which is this line that runs down the middle. And the last thing we found was the vertex by plugging in. All right, and then the last thing that we need to practice, just because you need to keep seeing it over and over again, is domain and range. So remember, domain is going to be all real numbers, and range is y. I know I can get the range, the y value from the y part of my vertex, and then I need to think, is it greater than or less than? And because this graph is opening down, it's going to be y is less than or equal to 4. So those are my domain and range values. All right, so with all of that, you should be good for tomorrow.